do you see? Do you see a green light bulb? Or do you see an array of two-dimensional colored pixels on your screen right now? And your brain says to you, that is a three-dimensional object in green. And how do machines see that? Let us do a journey together in the next minutes, a journey across a concept called PXL+, an idea and envision which says combining two or several data sets of sensors together to create a benefit for the flexible automation. Let's take this green light bulb as an example for all the difficulties, problems and tasks which are out there to solve to push the flexible automations to further limits. Let's be honest, reality is more complex than a light bulb. The tasks out there are defined by complex geometrical shapes and by objects which are sometimes really difficult to handle for robots or systems or any automated entities. Taking an example, different than this, out there, different texture, different color, and different complicated shapes are there, and modern tasks like bin picking or flexible detection are for humans kind of easy. You as a human, you are looking at this part and you see extremely fast the texture of this object, the size, and you can detect holes and screws because you know how a screw looks like. And your intelligence and your experience are helping you to detect, to segment, and to inspect this part. For automated technology, for sensing systems, this is a very special and sometimes a very difficult task. And this is exactly what we do in the next steps. Bridging the world between technology and humans and see where is PXL+ as a concept able to come to the point to see the same like we humans see and even see more. And we start again with a very easy step. We take this light bulb and we digitize it. We create a 3D geometrical shape and we see what we can do else, all basing on PXL+ technology. Let's create our first PXL+ dataset. And the base for everything is a 3D point cloud. And we need a sensor which is able to digitize in 3D environment. And one of the sensors we can use for that is the P&F SmartRunner Explorer 3D. A sensor coming soon into the P&F portfolio. This device is able to capture 3D scenes with a frequency of 10 Hz. So 10 point clouds per second, given by two cameras watching on a projected pattern in the middle of the sensor. With an accuracy range of around and better 1 millimeter, this device is able to give us the needed base for all our PXL+ measurements. Additional to this, we have to create the plus. And as a first very easy approach, we take an industrial camera. A standard industrial camera capturing a 2D picture of a scenery, and we combine this 2D picture with the 3D point cloud given by the SmartRunner Explorer. You want to see that? Let's dive into the software. See you later. Let's orientate ourselves first. What you see is a graphical user front end of the VMT multi-sensor software called MSS. This software connects to all needed sensors and gets the input data as raw point cloud, 2D camera pictures or any other sensor channel. The front-end appearance of MSS can be configured according to the user's wishes and needs. What we see here is a simplified interface with three major elements. A configurable status and result window on the left part, a configuration and control banner on the top, and a data visualization in the main window. What you can see is an
uncolored pixel point cloud of our green light bulb, which is digitized on its upper half. Clearly to see is its general geometrical shape of the glass body and also of the thread. Classic processing actions at this point are CAD matching algorithms where perfect CAD is fitted to the real 3D point scan in the best matching position for all points. Here you see the points of the real scene in light gray and a virtual CAD model in green, best possible fitted to the real scan. The resulting CAD position and orientation can, for example, be processed in MSS to create gripping points for bin picking applications. To make it more realistic, you see a non-perfect digitization including limited sensor resolution and noise in form of reflections. Especially these elements create difficulties in later data processing where our PXL+ approach generates significant advantages. So let's do the first and simple PXL+ step. Let's add a 2D grayscale camera picture as plus channel to the 3D pixel. Again, without CAD model fit, you see the real point cloud data, but this time with different shades of gray according to the photo captured by a 2D grayscale camera. Clearly visible now are the thread contours which were hard to distinguish before in the non-colored point cloud data. This is the first step for us, using PXL+ and the combination of 3D data with additional sensor information to increase our sensing and processing capabilities for complex scenarios.
The software platform that we just used is called VMT MSS. MSS stands for Multi-Sensor System. And MSS is a software product which is developed, extended and improved every day by a team of motivated developers working for VMT, which is part of the Pepperl+Fuchs corporate world. So using VMT MSS is a baseline for PXL+. It is the center where we can do all the magic of bringing the pixel and the additional information together, where we can do the calibration processes, the segmentation, the inspection, which is creating just a tool set for you to give you a solution package which can be perfectly adapted to your needs and to solve all the tasks that are out there to push the flexible automation. PXL+ and the grayscale image, so a gray shaded 3D point cloud. What can it be used for? What is a practical example to solve with such an approach? Imagine you've got a bin, automated bin picking, and inside this bin there's a chaotic scenery of different parts, unsorted environment, and the task is to automate this process of picking apart and taking it out of the box. The classic approach nowadays is to create a 3D point cloud of that environment and to iterate a CAD around the point cloud until it fits in a certain position and repeat this process until several parts are detected by the software. Classic problems in this strategy are, if you iterate this CAD file around the data, it consumes a lot of calculation time and the robustness of the system is limited. But imagine now, how do we humans solve this problem? We look into the bin and we combine the 3D information given by our brain using our stereo vision system we are equipped with, and we create a very intuitive approach to grip a part out of the box. But technology works different. The 3D point cloud doesn't care about the texture of the parts, and only with a PXL+ approach, where we combine a 2D image in grayscale and a 3D point cloud, we are able to segment parts and cut a region of interest out of the 3D point cloud and use this region of interest for further calculation. That speeds everything up. That's creating a better robustness of the system, and that is improving the complete automation process for example, bin picking applications. Are you ready for the next step? Are you ready for a next channel, a new plus information for our pixels? What we did so far was we created a gray shaded 3D point cloud. But what happens if our scenery changes? What do you see right now? Do you see two different light bulbs, one in blue and one in green? And how can we distinguish these two light bulbs by a machine? With our system right now, both of them are gray. But now we will change the 2D camera in grayscale with a 2D camera with color information, and we will attach the color information to every pixel of the 3D point cloud. Let's see how that looks in VMT MSS.
Here you see again the raw point cloud data visualized in VMT MSS. This time, two different objects can be interpreted which are representing the two light bulbs shown in the video before. The raw data makes them look pretty much the same. Given by their identical geometrical shape, it is not possible to distinguish between the blue and the green bulb. Let's try again to use a grayscale camera picture as additional Pixel Plus channel. As you can see now, the two objects get additional information in shade like already seen in the demonstration before. But still, the difference between the two light bulbs is only given by small gray shade offset. Let's now do the step and substitute the gray image to color image to create a plus channel with color information. Now the situation is totally clear. Due to the blue and green colored pixel, it is now easy to select one of the objects by their corresponding color. See how every single point cloud pixel got a new appearance, like a painting or color coding. The pixel on the green glass surface are all green, the pixel on the light bulb thread still have their gray color given by the metal surface. With VMT MSS, it is possible to use this color information to process selected areas or objects for applications like bin picking or robot guidance.
So here we are. Technology is able to see the same as we are able to see as human beings. A 3D geometry of an object and an overlay of color information over it to create a Pixel Plus colored point cloud. But why did you burn your fingers in your kitchen on your hot cooking pot? That's an easy answer, because you, as a human being, are not able to see temperature. If you could see temperature, you can see, oh, this cooking pot is too hot to touch, don't do it. And using the Pixel Plus concept, we are able to add an additional channel to the 3D points. This channel can be an infrared thermo camera creating a 2 image of a thermal scene, and this can be attached to the single points of the point cloud. Let's do an easy example. We love light bulbs. And the riddle is, which one of the light bulbs was switched on before? Which one is hot? And as a human being, there's no chance to see it. And using Pixel Plus, we can distinguish that light bulb from that one, because one of them is hot and one of them is cold like the others. And even more, what about if I touch one of the light bulbs for 2 seconds and create a thermal fingerprint to detect on the light bulb? Using Pixel Plus technology, we are able to see this thermal fingerprint on the light bulb. Let's see how that looks in MSS.
We start first again with our scenery only as a 3D point cloud. All pixels are light gray and you can see the digitized array of light bulbs like shown before in reality. Now we focus in on 3 of them and activate the Thermo Image Plus data channel, produced by the additional 2D infrared camera. Depending on the detected surface temperature, the pixel color is now spread between green for cold, over yellow and orange, to dark red for hot. And there it is. One of the objects is clearly marked by its temperature and therefore easy to separate from its neighbors. Question here for you. Do you see from which angle the plus channel information was taken? Now, let us make it more difficult. What about the thermal fingerprint? Is it possible to detect a thermal marker on the objects? The third dataset, which is shown now, shows a pixel plus capture after a 2-second finger touch on the right light bulb. This heated area can be clearly made visible in the scan and processed further by MSS. Do you see the 3 different kinds of pixel in this scan? Black pixel do not have a plus information. The colored pixel are the true pixel plus area with cold surface in yellow, and the red zone with an increased temperature area. Using Pixel Plus, we can automatically find anomalies or defects on objects and identify, mark or measure them for further processing.
So there we are, Pixel Plus, combining different data channels like color, like temperature. Let's do the next step. Let's do the step into the future and let's combine more delicate elements and more complex structures to the 3D point cloud. Imagine again, we take the fingerprint and we can use Pixel Plus technology using a thermal camera to create an environment where we can detect the fingerprint on the light bulb. And we use classic vision technology in 2D to find the blob zone of the fingerprint, to detect the center of gravity, and to create a coordinate system as a calculation result. And now let's take this position, this orientation, and map this orientation to the 3D dataset. So now we combine one pixel of the 3D dataset with a calculation result of the 2D vision step before. By this, we are able to create a situation where we use the advantages of World A 2D vision technology with artificial intelligence, image processing, and all that good stuff, and map the results to the 3D world. And this mapping process can be in reality extremely useful. Imagine the fingerprint, imagine the coordinate system. We can now say, where is the fingerprint, in which orientation, at which place on the light bulb. And if we go into a practical application, if we want to find an area on an object, and if we want to control a robot to go exactly to that place in the right orientation to work on this place on the 3D surface of the object, we can do that in MSS. And let's see how that looks.
We start again with a thermal fingerprint on one of the objects. But this time, we go another route. Let's wait until we map the infrared 2D data on the 3D cloud and do some action before. Image processing on 2D pictures is a common technology with a lot of highly optimized algorithms. Here, we will detect the center of the fingerprint zone by applying a center of gravity algorithm. This is a very easy example for a lot of more complex 2D algorithms, including searching, identifying, or clustering. So imagine that we found the fingerprint's center of gravity in the camera picture and identified the corresponding 2D pixel. What you see now is a further step using the created result of identifying the 2D center pixel. Mapping this exact 2D pixel into the 3D point cloud, it is now possible to use the 3D surrounding of it to calculate the surface plane. Doing this, we created the perpendicular vector in the exact fingerprint center as you can see in form of the yellow cylinder. And this is exactly what is needed to guide a robot not only to a correct position, but also to work in the needed orientation on the object. This can be used in every application where not only a robot position, but also its orientation decides for process quality, like automated polishing, grinding, or drilling.
Let's do a wrap-up. We are coming to the end of the journey, and let's wrap up again. What means PXL+ right now for us? We started with PXL+ as a concept. It is a concept, it is a brand, it is an idea of combining 3D and different data sets which can be additionally attached to the pixels. That's the technology. Another part is the software, which creates a platform to do all that applications, to have all the tools on hand. The third part is the competence and the experience of the people to create measurement environments, to create the data sets, to go out there into your facilities, to digitize everything around, or to find the right setup to measure your parts. And the fourth part, which is rounding everything up, is the drive for innovation. It is our consultancy power. It is our knowledge and our motivation to further develop the idea of PXL+. Currently, Pepperl+Fuchs is working on 8 different solutions for acquiring sensor data for the 3D point cloud. Scanning, snapshotting, point cloud generating, we are constantly improving this idea because we see the vision that a concept like PXL+ is turbocharging our solutions to help you out there solving all the needs that the flexible automation in our complex world is creating. Are you curious about PXL+? Do you like to do a hands-on? Do you like to feel how multiple channel sensing is? For the Pepperl+Fuchs Digital Expo 221, we created a game for you where you can deep dive into the virtual world, where you can get in touch with PXL+ and where you can experience the feeling of seeing gray, seeing colored, or seeing whatever else. So don't miss the chance to come to our Digital Expo and to get into the game and challenge us with your point records that you can achieve. Thanks for watching. Thanks for your time and energy, and hoping that the concept and vision of PXL+ was getting a little bit closer to you. And the next time when you burn your fingers on a hot cooking pot, think at Pepperl+Fuchs. Thanks a lot.